Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Suzy. And if you have any questions on your homework today, you can call in Bakersfield 636-4357. From San Luis Obispo or other outlying areas, you can call 1-866-636-6284. You can also email your questions to dothemath@kern.org. You can watch us online right now, dothemathonline.net, and you can look for us on social media, Facebook, Instagram, Twitter, and YouTube.
All right. Hey, did you happen to watch the Super Bowl over the weekend?
I actually watched the Kitten Bowl instead.
Oh, okay. Isn't there like a puppy thing too, or they pick
Yeah.
the team or whatever? So anyway, pretty exciting game, and
Yeah.
we'll get into that in just a couple of moments. We have a very special guest in studio. We will be heading out live to Van Horn Elementary, checking in with Devin and seeing what's going on out there. But before we get to any of that, let's first take a look at today's Math in the News. All right, so the Super Bowl was on Sunday, and do you have any idea what happened, or who was in it, or who played?
Yeah,
or anything?
the Eagles won.
All right, there you go.
Okay.
So you're aware of what's going on.
I know what's going
Okay.
on, yeah.
So let's take a look at the photographs that we have right here. So we have one with the Arizona Cardinals on some T-shirts here. Here's with the Steelers winning a Super Bowl, and the Tampa Bay Rays winning a World Series. Now, I don't know how much of a sports fan you are, but do you notice anything about any of these photographs? Anything that might tie them together or anything odd about them?
Well, I was looking at the Roman numerals, but then they don't all have Roman numerals.
Right. Well, the
But
thing is
The
that they're
champions, yeah.
they all have champions on them, but they're all losers.
Oh,
So, much like
Okay.
this year, the shirts and hats that they made up for the New England Patriots winning the Super Bowl obviously can't be sold and go out.
right.
So what they're going to do is they're going to have to do something else with those. So Good 360, a charitable organization based in Virginia, handles excess consumer merchandise and distributes to those in need overseas. The losing team's apparel, shirts, hats, sweatshirts, things like that they give them right after, they're going to be kept in inventory locations across the United States. Following the game, what they do is they figure out where the goods can be best of service and send them off there. Now, they took over this distributing of goods in 2015. For 2 decades prior to that, there was another company, World Vision. They collected all the unwanted items, and what they did is they sent those off to different countries. So some places like El Salvador, Haiti, when places have floods, earthquakes, ravaged by natural disasters, and people need clothing, they can send these people clothing, and that's what
Perfect.
those goods are
Yeah.
used for. Now, how do we tie this all into math?
out.
Here we go now. T-shirt sizes. So let's go ahead and take a look at some T-shirt sizes and how they go ahead and do these. So you can see that the first length that we have is the shirt length. So that's the blue line going from top to bottom. And the way they do that is every inch goes up for the next size. So here they're doing it by 1 inch. The width going across the chest, they 2-inch increments there. And then we can see the sleeve length, so that would be up where the collar is all the way to the bottom of the sleeve. And that It's all over the place, but it's
yeah.
usually like, about a half an inch, an inch and a half, so that one's kind of all over the place. But it was kind of funny to see the different lengths, because I wouldn't have imagined the sleeve length going from the collar. I thought it would have just been
Yeah.
from the shoulder down, but that's how they measure those. And then the chest, I mean, thought maybe it would have been up a little higher,
Yeah.
but anyway, you can see how they do that in both inches and centimeters there. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. In studio with us right now, we have Alessa. How are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Miller Elementary and I'm in 6th grade.
And that is home of the Mustangs, is that correct?
Yes.
The Miller Mustangs? Have you been a Mustang for a long time?
Yep.
How long?
Since kindergarten.
Since kindergarten. All right. So you've been there. And what is the best thing about 6th grade so far this year?
I don't know.
Do you like any of the books that you're reading this year?
Yeah.
What's the best book you've read so far? You guys read books together in class, or are they just kind of stories?
Together sometimes.
Together you guys do some of those?
Yeah.
All right. Have you been to Camp Keep, or are you guys going to Camp Keep this year?
We're going to Camp Keep next week.
You're going next week. Well, it's a good thing I got you on the show to make you do a little work before you go to Camp Keep.
Yeah.
So you've been studying a little bit about things before you go over there, right?
Yeah.
And you know what? When you go to Camp Keep, I want you to do me a favor. I want you to think of one great thing that you do over there during the week, and then call us the next week and let us know. Can you do that? All right. Well, you know what? Until then, we're going to put you to work. Are you ready?
Okay.
All right. Head on over to the board with Suzy. We're going to get you working on one of your homework problems here. So you've got ratios and proportional relationships that you're working on. Let's go ahead and we'll take a look at number one that you're working on right now. Kathy and Joe are baking pies for a bake sale. Kathy baked 4 apple pies and 3 blueberry pies. So I guess you can put up there K, we'll just abbreviate for Kathy. And we'll put her at 4 apple
Okay.
and 3 blueberry. All right, now the rest of it,
Fraction bar in between. Yeah.
Joe baked 9 apple pies. So he's got 9 apple and 11 blueberry. Now the question is, who baked a lower ratio of apple pies to blueberry pies? So girls, go ahead and solve that problem.
Okay, so let's put the fraction bar here, okay? All right, so I'm going to erase that. Okay, no, it's okay. You're doing great. So, you know what a ratio is?
Yeah.
Okay. So I like that you put the A and the B there, because then you made sure not to switch them around, because the apples have to be with the apples and the blueberries have to be with the blueberries. So we have to figure out which ratio is lower, 4/3 or 9/11. Do you have any ideas how to start?
No.
I want you to think about what equals 1.
3 wholes and 11 11ths. Yeah.
Okay, so, whoops, I was erasing. So 3/3 would be 1, right?
Yeah.
And 11/11ths would be 1. Okay, so this one is,
1/3. 1 and 1/3.
so it's more than 1. Okay, and this one is
Less than.
less than 1. So if this one's more than 1 and this one's less than 1, which is the lower ratio?
This one.
That's correct. That's correct.
All right, there you go. First one done, just like that. Nicely done, Alyssa. 636-4357 is the phone number. Don't forget, if you're calling from San Luis Obispo County and we do one of your math problems, you'll automatically be receiving free ice cream, courtesy of our friends at Doc Bernstein's Ice Cream Lab. Right now, we're going to head out to the Van Horn Elementary and see what Devin's up to.
Hey, thanks a lot, Mike. We're here live at Van Horn Elementary School working with the after-school program. We've got about 20 or so of our students here ready to work out and think about math in a really unique way. We asked them if they were nervous. They said no, and so it's time to put them to the test if they're so confident. These people around here think they got everything down. So we're going to go ahead and really start to explore the ways in which we see numbers in our world. Math is a very visual medium. A lot of times we associate math simply with new numbers and adding and subtracting and processing like that and calculating. But today we wanted to explore the different ways in which we can see the relationship between different values. So I've gone ahead and put a little challenge together for our students. It's going to seem straightforward at first. But as we dig deeper into what we're being asked to do, you're going to start to notice a lot of different things about ideas that you think you've always known about. So what I have prepared is a series of sets of circles. Now what I'm going to ask each of our groups to do, and as you can see, each of the groups is sitting around each other in a circle with some space in the center to work off of, is I'm going to ask each of these groups to assign a number value to each of the sets of circles that they're going to see on our board here. And they're going to have lots of time to do this, and I want to see if they can identify something pretty quickly as they start making these associations. And they're going to have conversations, so it is going to get a little noisy in here, and that's great. And we're going to check in to see what sense they're making of these values. So, are our groups ready to start looking at some circles? Yes. Let's go ahead. So please direct your attention to the screen. And I want to see if you can assign one numerical value, one number value, to each of these sets of circles. Have the conversation. Are you ready? Go. All right. So many of you at home have probably already noticed something pretty straightforward about these sets, is that they represent a sequence of numbers starting at 1. And you could probably sense that this pattern is going to continue all the way to the end with our final value. So we're going to see how quickly these students make this association, because once they do, we're going to ask them to identify what they notice about the different arrangements of circles. Because they're going to recognize, using the visuals of these numbers, some things about numbers that they may not have seen before based on how they're arranged. So let's go ahead and check in with some of our groups here. So you guys noticed something about some of these circle sets. Could you describe some of the things that you noticed? So some of them are in groups and some of them aren't, okay? Were you able to assign number values to all of these yet, or just some of them?
Just some of them.
Okay, so can you give us an example of one that you have given a value to? So is that the one that you wanted to start with?
Yeah.
Okay, so what do you think so far for a number value of that last one?
They're in groups of 4.
They're in groups of 4, okay. So you were counting by 4, so how many groups of 4 were there? 7. So you have 7 groups of 4. So how many circles are in that set then? 28, okay. So you've identified that that last value is 28. Try one that is either above it or next to it to see if you can start putting some values together, okay? And we'll see what you guys come up with. So really interesting approach. They decided to do the last one first. I think sometimes we always look for a sequence to start somewhere, and some groups may have started elsewhere. Let's check in with another group. Let's see. Let's go with you guys. How's it going, everybody? So, have you assigned some values to some of these dot sets?
Yeah.
Okay, go with the first. Give me an example of one that you found.
We were just talking about how they were like in tens.
So there's one. So explain which one you see that's in tens.
Cause I think cause I can't talk today.
You can talk every day, man. We're here. So,
Look.
do you see one that you would identify as 10? The middle one. Would you say? So this one right here is 10.
Yeah.
Okay. How do you know that that's 10?
It's because it has 10 in it.
So okay. So you counted 10 dots in there. Was there a way that you counted 10 more quickly than just one by one?
But 10 like 5, 10, or something like that.
Yeah, something like that.
So you tried to find groups. Do you see some groups here that you could count quickly? Twos, right? You saw some twos? So you saw 2, 4, 6. So what you guys saw was that you saw 5 groups of 2 to get to 10, to show that that's 10. Could you use that logic to make sense of all the other images? Try it out and see what you come up with. So they went with a friendly number to try to find first. They recognized that one of them had to be 10, so they wanted to see if they could recognize which one would be 10. Let's check in with one more group over here.
If you count all of the circles, they go all the way to the number 7. But all the circles can represent the number that it's supposed to represent.
So you recognize that the entire row are the numbers 1 through 7, okay? What do you think that means for the row below that?
That it keeps counting by ones.
So this first one in the second row would be how much?
8.
8, okay? So you could go all the way to the end, and what do you think that last one in that row would be?
14.
14. So you're starting to recognize kind of a sequence of the counting sequence, almost like you can predict that that's going to continue all the way through to the end. Okay. Continue with that, see if that works out. So they use the counting sequence starting at 1, starting with the very beginning, the single dot to identify that as 1. So you can see this is all the numbers 1 through 28. They're going to continue to analyze this. When we get back, we're going to see if they recognize patterns and what that means about the numbers. But for now, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, Devin, and nice to see how those kids at Van Horn are starting to tackle that problem. Patterns all around, and that is the key to that problem that they're working on right now, seeing if they can see those patterns and then trying to figure out, because I know there are going to probably be some prime numbers in there that will have the same design, shape, square numbers, and different things like that. So anyway, we do have phone tutors available until 5:30. We have Alessa in studio. We're going to give you a break for just a moment, all right? We're going to go to the phones right now, and a 7th grade student from Stern. How are you, Gage?
Good.
And you are a 7th grade student, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on today.
Go ahead.
Huh?
You can read it when ready.
9x plus 10 equals 40.
Okay, 9x plus 10 equals 40. Did you have a word problem that went with that?
Actually, no, I can't solve it.
Oh, you can't solve it. Okay.
No.
So have you done two-step equations yet?
Equations, yeah.
Okay. So I have 9 times x, and then I have 9x plus 10.
Yes.
Do you know which one I could get rid of first?
Okay, you put, because you know where the equal sign is?
Mm-hmm.
Put a line through it and minus 10 from both sides from 10 and 40.
Okay. So I'm going to subtract 10 from both sides of the equation, like that?
Yeah.
Okay.
Yeah.
And then this turned into 0, right? So I have 9x is equal to, what's 40 minus 10?
It's 30.
30. Okay. All right, now do you know what to do?
Okay, drop down 30 and bring down the 9x and equal 9x 30, and then do it on the other side. Do 9x equals 30, and then do the same thing you did on 9x plus 20.
So do you know what the inverse operation from multiplying is?
No.
Okay, what's the opposite of multiplying?
Division.
Right. Okay, so divide by 9, divide by 9. Okay. And so x equals 30/9.
Uh-huh.
And do you know how to change that into a mixed number?
No.
Okay. 30 divided by 9, okay, I'll show you, is 3, okay? So there's 3 groups of 9/9.
Uh-huh.
And then there's 3 parts left over, and they are 9ths. So that's 3 and 3/9,
Uh-huh.
which is 3 and 1/3, okay?
Yeah.
But I do have a question for you. I saw your problem ahead of time, and I'm pretty sure there was a word problem there. No? That went with it?
Yeah.
Okay, so can you read the word problem?
Luis needs $40 for a video game. He has 10 and makes 9 an hour. Write and solve an equivalent showing how many hours he needs to work.
Okay.
Okay, so what you came up with was the number of hours he needs. Okay.
Okay. Now, if he starts with how much money? $10?
Yeah, $40.
No, he starts with 10,
Yeah.
and then he earns $9 per hour. Now he needs to get to 40, but could he get to 41 or 42 or 43? Yeah, he has to have 40 or more. So you can make it into an inequality. Now you would solve it the same way, but when you're earning money, you can't get less than 40, but if you need $40, you get 40, 41, or 42. So then, when you solve it, okay, you get the same thing, but you would kind of have to think where you're working. Can you work 3 1/3 hours? Whoops. If not, you might have to work 4 hours. So sometimes real life gets in there.
Does that make sense to you, Gage?
Yes.
All right. Well, you know what? For doing such a wonderful problem right there, we're going to send a Cubby's Pizza your way. So congratulations on that. I do believe we'll be visiting Cubby's tomorrow and then talking about their new location that's opening up. And Gage, if you have some more problems like that, you need some more help, do remember we have phone tutors available until 5:30. All right, young lady, you rested up? All right, back to the board with you. We'll take a look at number 2 on your homework for Alessa. Once again, working with ratios and proportional relationships. Lucy drank a total of 6 liters of water over 2 days. So she had 6 liters of water over 2 days. So 6 liters in 2 days.
You can simplify it later. Just write 2 days. You're doing just fine. Okay.
So it says, how many liters of water did she drink after 6 days? Solve using unit rates.
Do you know what a unit rate is? I think I could give you a hint. So you have 6 liters of water, goes with 2 days. Now for a unit rate, I want to know how much for 1 day. So how could I get to 1 day?
Divide.
Okay, yes. What's 6 divided by 2?
3.
Okay, so it's 3 liters for 1 day. Okay, so that's the unit rate. Okay, now I bet you can do the rest of it by yourself. It says, how many liters of water did she drink after 6 days? We know how much for 1 day.
18.
That's correct. And what did you do?
I just multiplied 6 by 3.
That's right. This is how much for 1 day. So, whoops. If you're doing 6 days, you're going to get 18 liters. That's very good.
There you go. Nicely done. And for doing some great work right there, we will be sending you, along with many other things, to the Bakersfield Condors. So congratulations on that.
You can come back.
Nice to see everybody doing some great work today. And right now we're going to go back to the phones and speak with Brian. How are you today? Hello, Brian. You there, Brian?
Yep.
All right.
Okay.
And you are also a 7th grade student, correct?
Yes.
All right. Let's hear the problem that you're working on.
Okay. Jose is building a vegetable garden in his backyard. It has an area of 2x plus 10 square feet. What is the dimension of the garden?
Okay, so in order to get the dimensions, we have to have something times something equals 2x plus 10, right?
Yep.
So one way to do that is by factoring. For instance, if you had something that was 12 square feet, it could be 1 by 12, it could be 2 by 6, or it could be 3 by 4, right? It could even be 24 times a half, but we won't deal with that right now, okay?
No,
So,
yeah.
how do you factor this?
Put the 2 out front. Then put x plus 5 in parentheses.
Okay. Now, I'm going to show you how I get from here to here, okay?
Okay.
All right, so 2x is 2 times x, right?
Yep.
And 10 can be 2 times 5. Does that make sense?
Yeah.
And clearly, when you looked at this, you knew that 2 went into both numbers. Is that right?
Yeah.
Okay, so I can factor out a 2 because both terms have a 2 in it. So I put the 2 out front, and then what's left, I have x plus 5. So there it is. So you could have a vegetable garden that was 2 times x plus 5. Does that make sense?
Yeah.
Now there's actually a lot of right answers, because you could have 1 times 2x plus 10, right? Okay, so that's 2 answers. Do you have any other questions about that?
No.
Okay, good job.
There you go, nicely done. You know what? Great problem, great prize coming your way. We're going to send you off to Chick-fil-A, so congratulations on that. 636-4357 is that phone number. Don't forget, outlying areas of Kern County, numbers toll free. 1-866-636-6284. We'll give Alessa a break, get back to more phone calls right after this. Today we're in San Luis Obispo County. We're at Shandon Elementary School, and today we're here to... Well, today we're at Shandon School, and I've got 8th grade student Isaiah with me. And how are you today?
Good, and you?
I'm wonderful myself. You ready to go?
Yeah.
All right. Why don't you grab a marker right here? You can grab whatever color you like. All right. So with school, let's just say it's your school, wants a new playground by cleaning up an abandoned lot shaped like a rectangle. So let's go ahead and just put a rectangle up there first. All right. The students decide to use a quarter of the playground for a basketball court. So if we're going to use 1/4 for basketball, we should probably break this up into how many pieces?
1/4.
1/4. All right, so we'll break it into fourths. There we go. So 1/4, I guess if you want to, you can just label it basketball court, shade it in, and label it 1/4. All right, and 3/8 for a soccer field. So how are we going to make 3/8 if we have fourths up here right now?
We put another 4.
Okay, so if this is a fourth, how can we turn this into eighths?
4. You split it up.
Okay, see if we right now we have 4 pieces, right?
Yes.
How can we put one line and make 8 pieces?
In the middle.
There you go. So why don't you just do that? All right. But what we're going to do is we're going to leave this whole thing, the basketball court, because this is 1/4, right?
Yeah.
Okay. So now it says 3/8 is going to be for the soccer field. So how do you want to put 3/8? How do you want to shade that in? All right. So 3/8 is going to be for soccer field. So why don't you go ahead and label that soccer? All right. Now the question says, how much is left over for swings and play equipment?
3/8.
Okay. So you can go ahead and write that.
Okay.
So now let's write it the way we actually solved it. So how much was used first?
1/4.
1/4. So let's go ahead and write down 1/4. And how much was used for the soccer area?
3/8.
So we're going to add 3/8. And how much was this all together now? And what are you doing right here? Because I know what you're doing, but for kids that are just learning this process.
Oh, we have to get a common denominator.
Right.
So 2 eighths, 5 eighths.
Right. So we had 2/8, which was the same as 1/4. We added 3/8, so you had 5/8 altogether. We know that the whole thing is 8/8.
Yeah.
So we subtracted that, and by drawing the picture, we didn't even have to work out the problem because we already saw that what was left was
3/8.
3/8. All right. All right. So let's just go ahead and we'll write it out. So we'll put 8/8, which is the whole area,
Yeah.
and we'll take away what was used,
Minus 5 eighths,
and that leaves us with,
3/8.
there you go, Isaiah's. Nicely done. And a big thanks to all of the students that we were able to work with over there at that school in San Luis Obispo County. Don't forget, that phone number is toll free for you guys over in San Luis Obispo County. Right now, we're going to go to another school, this one in Kern County. We'll go back over to Van Horn and visit with Devin.
Hey, thanks a lot, Mike. Back here at Van Horn Elementary School, our team has been working hard on these patterns, and they've came up with some really inventive structures for how to do things effectively. Now, they had one pad, but 2 markers, and so they were trying to figure out ways to make the work go by faster as far as recreating all of these sets of images, until somebody realized, why don't I just take one set and break it up into 2? Do twice the work in half the time. So I wanted to throw this challenge out to everybody, and some of the groups have already kind of taken it upon themselves as they've created these by hand. But I want to see if you could join us on this second look at some of these images. All right, if you can hear me, clap once. Stuff to do if you're holding the marker, I get that. So you've had an opportunity to recreate some of these images, and in doing so, you got very hands-on with some of these values. So what I'd like to see if you could discuss in your groups is, are there any patterns that you notice? Are there any relationships between some of these numbers and values that stand out? So what do you notice that some of these have in common, other than they're all circles and dots? I'd like everybody in the group to share at least one thing they noticed with each other, and we'll come around and ask some of your groups what you noticed, okay? Go for it. I wanted to start off with our group back here because they noticed the relationship between 6 and 18 that I think leads to a lot of other connections. So let's go ahead and visit over here. So everybody, I wanted to start off with you guys because of the connection that you made with 6 and 18. Could you describe what that relationship was?
They looked the same shape, but this one had 3 and this one was only 1. Because this one's less and that one has more.
Right, so you noticed though that this set of 6 here looked almost identical to the value 6. So how would you describe the number 18 in relationship to 6 then?
Because, well, there's 3 of them.
3 more, and 6 times 3 is 18.
So you're seeing this as now 3 groups of 6.
Yes.
So I wonder if that relationship exists elsewhere in this. Do you see that pattern exist with 2 other numbers?
Yeah. Well, not exactly.
Where you notice that one number is made up of smaller versions of the same number.
Because I was looking at the ones with circles, but I noticed that each circle had less dots than the others.
So I want to get back to the circles a little bit later on because they've noticed something about those that really stand out amongst the rest. See if you can determine what all those circles have in common with each other, and see if there are other versions of that circle that are maybe comprised of smaller numbers of dots, okay? So what would be the next circle lower than 11? So talk about that and see if that pattern continues. Let's check out over here to see what you guys have discovered in this set. So have you guys noticed any patterns in some of your numbers?
They're the same shapes.
So give me an example of same shapes appearing.
Like, a lot of them have like circles.
Okay.
And a lot of stars. And
So,
these,
go ahead.
Some of them too are the same, like they have the same shape.
That's an interesting, because that other group came to the same realization with 6 and 18, how the 18 was made up of 6s. The 18 was made up of 3 6s. Now, I wonder if that's true for something else, for two other numbers, where a larger version is made up of smaller versions of another number. Do you see anything like that? You got one? What do you notice?
Like some of them are just triangles.
So give me an example of two that are made up of triangles.
There's 27.
27, right down here. Okay.
27 and
9.
Yeah.
So now,
I'm trying to see if there's others.
so let me ask you this: how many sets of 9 were in 27 here?
How many sets of 9? Sorry.
So this is a set of 9, right?
Yes, 9, 9, and 9.
So how many sets of 9 do you have in 27?
27.
3. Well, we have 3 to get to 27, right?
Oh yeah.
So 3 9s to get
So-
to 27. 3 9s to get to 27. And you saw that there were 3 6s to get to 18. Is that true for every larger number that is made up of sets of 3 groups?
No.
Well, let's take another one. Let's start off with 3 then. Okay? What would be 3 groups of 3?
3 groups of 3 would be 9. 9.
1, 2, 3, 3s. Very interesting connection with 3s. Let's go to check out another group over here. So, what was something that this group noticed as far as a pattern?
So, they noticed that each row, like each column of the problem, they each increase by 1.
So every single time you go, it increases by 1 across, right? Do you notice anything about going down?
No, we haven't looked at it.
Well, let's take a look at that right now, okay? Let's start off with 1. What is the value directly beneath 1?
8.
8. Now, what is the relationship between 1 and 8? By how many up do you have to go to get to 8 from 1? 7. Okay, now let's look at the next one over, 2, and go down. So, 9. How far apart in 2 and 9?
7.
7. So, is this a pattern that holds true with every number? As soon as you go from 1 and go 1 beneath that, the difference between those two is 7. Have a conversation and see if you can find more examples of that, okay? So this group used a very different approach on making a relationship using patterns. They didn't simply look at groups of values and factors. They decided to look at a pattern of difference, of addition and subtraction. They noticed that each one beneath is 7 more than the one above it. And so that holds true through the entire pattern. So when we come back, we're going to ask the kids to get a little bit creative with some of these visual patterns. We've explored 1 through 28. But what else could we create? So when we come back here to Van Horn Elementary, we're going to give you an example of what kids have made for 29 and 30. What do you think those would look like? If you want to have a chance to draw that on your own, feel free, go ahead and share that with us here on the show. But for now, we're going to send it right back to the studio. Mike, take it away.
Thanks for that, Devin, and nice work that the kids are seeing those patterns out there, and a lot of different things you can visualize and figure out with that display that he has up there with all the different ones. Good idea for the kids to put them on different Post-its, and that way
like
you can
that
kind of
part.
manipulate them around
Yeah.
a little bit easier as well. We do have phone tutors available until 5:30. We're going to go back to the phones right now. Another student from Stern. Allie, how are you this afternoon?
I'm good.
And are you in 7th grade as well?
Yes, I am.
All right. As soon as you're ready, let's hear that math problem that you're working on.
Okay. Write a linear expression that represents the perimeter of a square with the side length of 1/2 x plus 4.
Okay, so 1/2 x plus 4. And what do you know about a square? Do you know anything about a square?
That it equals 90.
Well, there are 90-degree angles, that's true, but do you know anything about the sides of a square? What makes it a square?
That all sides are equal.
That's right. So I need to do 1/2 x plus 4, 1/2 x plus 4, plus 1/2 x plus 4, plus 1/2 x plus 4. Now, that could take a long time. Can you think of a different way I could do it?
Not that I thought of now.
Okay. Ooh, I keep doing that. do you agree that you have 4 of these?
Yeah.
So, either way is fine. I can add up all the sides, or I could multiply the sides by 4. Which one do you want to do?
Multiply it faster.
Okay, so do you know how to use the distributive property?
Yeah.
Do you know what 4 times half x is?
No.
Okay. Now, when you're multiplying fractions, what do I need to do to that 4? Put a 1 under it. Do you remember that?
Yeah.
Okay, so 4 times 1 is 4. 1 times 2 is 2. So I have 4 halves x. Do you know what 4 halves is?
4 halves.
Uh-huh. If you have 4 half pizzas, how many pizzas do you have?
2 whole.
That's right. Okay, so I have 2 wholes. So 4 times 1 half x is 2x. And should I put plus 4?
Yeah.
Well, I happen to know, because I know your teachers, that
Yeah.
you know about trick-or-treating, right? This 4 has to go to all of the numbers in there, right? So what's 4 times 4?
4 times 4.
Mm-hmm. 4 times 4.
16.
Right. Okay. Now, if I did it up here, I could have put all these half x's together. And again, that would have given me 2 x's. And then I could put down all the 4's together, and that would have given me 16. So the perimeter is 2x plus 16. Does that make sense?
Yeah.
Do you have any questions about it? Okay, good
Sounds
job.
like she's got it. If you do have some more questions like that, we do have phone tutors available until 5:30. Congratulations also on that, Allie. We'll be sending you to a movie of your choice at Maya Cinemas. So congratulations on that. All right, you well rested? All right, back to the board. Here we go. Time to get your homework completed as much as we can. Number 3, this is something you deal with all the time, looking for the better buy. All right, so the first option is you can get 4 sodas for $5.60. So you can get 4 sodas for $5.60. Or you can get 9 sodas for $13.23. And the question is, we'd like to know which is the better buy. So which one should we buy to save more money?
While you're working on that, I'm going to draw a picture up here, okay? Oops.
And that top price, Suzy, on the 4-pack is going to be $5.60.
Oh, thank you. Okay. Okay. So that is true that get $11.20 for 8 sodas. So how do you think you could, do you think you could figure out how much for 1 soda? How could you figure out how much for 1 soda?
By dividing 5.60 by 4.
That's right. 560 divided by 4. Let's see if we can, okay, I have this written down, so I'm going to erase that for you and let you do the division there, okay? Okay, so here, let's write it. I'm a little taller than you, aren't I? Okay? Okay. Go ahead. Okay, before you do this though, I'm going to just help you with one thing, okay? So 5 minus 4 is 1. That's correct.
Oh, yeah.
Very good. Yep, I didn't even have to tell you.
Okay. Then 6.
Mm-hmm.
Then
Mm-hmm. So this one is, I'm going to keep track of what the work you've done. Okay, so 140 for 1. That's a unit rate like we did in the other problem, right?
Yep.
Okay, now let's do this one. How can we figure out how much on this one?
by dividing it by 8.
Well, almost 8. 1, 2, 3. Isn't
Oh,
it a
9.
9-pack?
9.
Yeah, it's a 9-pack. Okay. So here, I'll get you started here. Is that too high? Okay. All right. Very good. Wait a sec. Okay, go ahead, go ahead. All right. I like how you know how to keep going, even if you run out of room. Good. Very good. You didn't forget the decimal point. So these are $1.40 for 1 soda, and these are $1.47 for 1 soda. So which is the better buy?
The 4-pack.
Okay. So why is this better when it's less?
Because
Do we want to pay less or more?
less.
We do want to pay less. So that's when less is more, okay? Less is better. Okay, very good.
Nicely done, and I like how, Alessa, you were trying to solve that problem first, where you multiplied the 4-pack to get an 8-pack, right? So kind of explain what you were thinking there.
I was thinking, since 4 times 2 is 8, and it's close to 9, like, even though you have 1 less, wouldn't it be kind of better?
Yeah, would it be, because you saw that it was going to be kind of close, because it was
Yeah.
$11.20, I think you came up with, right?
Yeah.
And the other one was $13, so that got kind of close when you had an 11-pack and a,
Yeah, and if the other one was an
9-pack and the
8-pack,
8-pack.
if the other one was an 8-pack, she could have got there in one step. Just
Right,
been
just
done.
doing that.
Yeah.
Well, you know what? Lovely work. Stay at the board. I've got another one for
Oh,
you there,
okay.
Hot Shot. Here we go. We're going to go in a different direction now, okay? Because something that you're going to be doing the rest of 6th grade, as well as when you get into 7th grade and 8th grade, is working with expressions and solving equations. So first what we'll do is we'll simplify the expression. So I'll have Suzy go ahead and write it up there, and then you can go ahead and simplify it. So we have 4, open parentheses, 7 plus 9y, and then close parentheses.
Have you worked with variables before, with letters?
No.
No? Let me show you something with numbers, okay? So what if I did 3 times 4 plus 5, okay? Now, do you think that would be 3 times 4 plus 5? Because do you already know that a number next to parentheses is multiply? Have you done that before? Oh, you haven't. Okay, so I'm going to put a little multiplication sign in there. Okay, a number next to parentheses is multiplication. And do you ever use the dot instead of the x? Oh, okay. All right. So we'll go back to the x. Okay, so 3 times 4 plus 5. Or do you think it's 3 times 4 plus 3 times 5? Which one do you think it is?
The top one?
Okay, so let's see. Now, have you learned order of operations?
Yeah.
So you know that this is 3 times 9, right? 3 times 9 is what?
27.
Good. Okay, so let's see what this one is. On this one, we would do this first, and that would give me 12. And what's 12 plus 5?
17.
Okay. And this, I have 12 and 15. And what's 12 plus 15?
27.
Okay, so which one is it the same as?
The second
The
one.
second one. And that's because it's 3 times the whole thing, not just the first number. Okay, because 4 plus 5 is 9. We're doing 3 times 9. Okay? So, now, if when you use variables, they're kind of like the blank box back in kindergarten, 9 times something. Okay? So now I'm going to change it back to a y. So y is just a number that we don't know what it is. Okay? So I can't do order of operations here because I don't know what the y is, do I? I have no idea what it is, so I'm going to have to do something else. And this is called distributive property. Some people do it with arrows, some people do it different ways, but I have to do 4 times 7, and then I have to do 4 times 9 y's.
And I'll give you girls a couple of seconds to wrap that one up.
Okay, so I have 28 plus 4 times 9 is 63, so I have 4
hold
times
on there,
9 was...
sister.
What?
7 times 9 is 63. You got the numbers
I
reversed there.
reversed
So
it. 36y.
there you go.
Okay. All right.
So does that make sense, Alyssa, kind of looking at it like that with distributing? So 4 times 7 is 28?
Yeah.
All right, good. Well, come on over here because I'm going to give you another one to work on because you've done some excellent work today, and I know that's something brand new for you right there. So while we go back out to Van Horn and Devin and see how they're doing with those patterns out there, we're going to have Alyssa work on some more expressions. All right, we'll send it out. Back to Devin.
Hey, thanks a lot, Mike. Back here at Van Horn Elementary School, wrapping up our challenge activity, being very visual about math today. And when we last left you, we dropped a challenge on our students here, as well as you at home, following some of the visuals of the arrangements of dots for the numbers 1 through 28 on the board behind us. What do you imagine numbers 29 and 30 would look like following the same pattern? And we walked around and noticed a lot of crumpled up little Post-it notes, and that's great because that means they tried something, they had conversations, and they moved on to another idea. So I want to share some of the ideas that we have here with some of our groups here. Starting off with the number 29. So this group was the first to really get into an idea of what 29 could look like based off of what they understood about the number 29. So could you explain your design for the number 29?
We did a circle of 29.
So we went with a circle of 29. Can you explain why we went with a circle for 29?
We couldn't do groups of 29 because 29 is an odd number, and if we have an odd number, there would be one.
That would be a remainder.
Well, so you couldn't divide it into an equal number of groups. Does that make it odd, or what did we say was the word for numbers like that? Where
Prime.
it was prime, right. So because you identified 29 as a prime number, you put it in a circle. Okay, now what's interesting about 30 is that you have a couple of different designs for 30. Could you explain both of your designs?
Well, this one has
Groups of 3.
and it equals up to 30.
This one has 3, 6, 9, 12. We're counting
by
three.
5.
Groups
So-
of
That 30.
5 inside. 6 groups with 5 inside.
So I almost want to say this is kind of like 10 times 3 to get to 30, or 10 3 times. And for this one, we identified 30 as 6 groups of 5 each. And you arrange the 5s very similar to how 5 was arranged up on the board there. So I think that's a really interesting connection we're going to make. So we had a group with 6 groups of 5 on 30, as well as 10 groups of 3. I wanted to jump in over here and kind of share in on our conversation about 30. So could you explain your arrangement for how you organized 30?
We did 6 groups of 5.
Well, it looks like actually we have 5 groups of 6. You're absolutely right on that. And you arrange the 6 very similar, if I could turn this upside down so our viewers can see this, very much using the form of 6 from up on that top row. And then they seem to be almost arranged in the pattern of the 5 to show that we have 5 groups of that 6. So I think that's a really interesting way of approaching that. And then what did you guys do for 29?
We did circle. 1 times 29.
Yeah.
That's all 29 circles. Yeah, that's the only way. Only the circles can make 29.
So if we did a multiplication expression, maybe we did 29 times 2. What do you think that would look like without drawing it? How would you describe it? If 29 is 1 circles, then 29 times 2 might look like what?
Like, it would be 2. Like 9, 2.
So it'd be like 2 circles of 29, right? That's really interesting. So you can do that with prime numbers eventually as you multiply up. I wanted to check in with our group here in the back as well. So you had an interesting way of approaching 30.
We used the
go ahead.
groups of 6.
So we had the groups of 6, so very similar to how another group did that. But we also noticed that you guys started off with something as well. Did you guys have a different way of doing 6 groups of 5, where it was arranged?
Whoa. I don't know. She's the one that drew, but she didn't.
Oh, he put that right on you. Wow, put you on blast. That's phenomenal. But we saw an arrangement where you had something very similar to this, except it had the groups where there were 5 in each group, and then there were 6 of those. Do you remember that?
Yes.
So I thought that was an interesting approach. And for the 29, it looks like you guys have that in a triangle, but what I think is really interesting is that it's still one single layer, very similar to the circles. So how did you guys get to that about 29?
Well, there's 11 rows right here, and there's 6, and then there's 1 left over, so we divide.
So you kind of used almost addition to add up different sets to get to that 29. But because it's still just one layer, that kind of makes it look like it's prime like these others. And is that true about 29, that it's prime?
Yeah.
So what ways do we group 29? How would we do that? We'd have to do 1 group of 29 or 29 groups of 1, like what you're saying. So really interesting approach. Thank you so much for your work. And thank you to everybody in the room for your approaches on how you tackle these problems. It's really interesting how we can look at the same numbers that have always been around us very differently. We can see a number like 30, for example, as 10 groups of 3, 5 groups of 6, 6 groups of 5. Even look at prime numbers a little differently. As long as we recognize that everybody's way that we see the same thing has value, power, and dignity, and allows us to see anything with a bit of a different lens. So that'll do it from here at Van Horn Elementary. For the last time today, we're going to send it back to the studio. Mike, take it away.
All right, thanks for that, Devin. Nice work over there at Van Horn with those Hornets working on the patterns today. Hey, we do have phone tutors available until 5:30. We'd like to thank Alessa for coming in from Miller Elementary, 6th grade student, been a Mustang for 7 years, huh? All right, you've got one final duty this afternoon. All of the students that phoned in, they have their name in here, and one of them can win 2 tickets to any CSUB athletic event. So go ahead, reach your hand in there, pull one of those out, and we'll see who the lucky winner is. And who is that?
Allie.
Allie. So there you go. So a 7th grade student from Stern. So congratulations to Allie going to a CSUB athletic event of your choice. Thank you to CSUB's athletic department. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.